Hello and welcome to another video. In this video we're going to be working on delete nodes from a linked list present in an array. And in this one you're given an array of integers and the head of a linked list, and you want to return basically the new linked list after removing all the nodes that are in this array. So this array is like the integers that you want to remove. So if we have this, we want to remove 1, 2, 3. So we're going to return this linked list. And here we want to remove all the ones, so get rid of all the ones, and so our new linked list will be 2, 2, 2. And then here we want to remove 5, but we have no 5, so that's fine. And I think they tell you that the linked list can't be empty after removing values, and it's like 10 to the 5th long. So let's take a look at this. Let's say we're trying to remove some numbers like 4 and 1 maybe. And so there's going to be a very common pattern that you can follow to either get rid of values in a linked list, reverse a list, or basically any kind of list modification, combination, any kind of thing like that. And I'll kind of walk you through how this is going to be good. So the first thing you want to make is a dummy node that will be the head of the result. So we're basically just say, like, let's just make a node over here. It's going to be the head of the result, and then we want to set our current node that we're at equal to it. So set cur node equal to it. So two variables, dummy and cur. So here we can have this dummy node. It will point here, so we can call this dummy. And then we can have this other one, maybe we'll make a green one, called the current, and it will point here as well. And essentially the idea is anytime we want to add a node, we're going to say where are we in our current node, and we will say the next node of our current node will be that node. So we're going to build up a list, and then the next node of the dummy node will be the head of our output. So we have one more node here. So let's say this is the head of the original linked list. Okay. And let's just walk through how this would work then. And then for these numbers that we don't want, it's pretty obvious that you're just going to want to have those in a set. So this will be a set. We just turn all our initial numbers into a set. Okay, so basically we go through a number and we say, like, do we want it or not? So this 5 we do want. So that means we're going to say, let's make the next pointer of our current equal to this guy. So we'll have a next pointer of our current, and it will equal this guy. And then we will move up our head. So what's going to happen here is this will go down here. So we make the next pointer of our current equal to this guy. Now this node still points to this, right? So we're going to move our current up, and then we're going to make its next pointer null. So we get rid of this connection. And then we do this, we basically repeat this. So we say 4 we don't want. So if we don't want the 4, we can just move up with our head. We don't really care. So we just move up with our head node and we keep going. 3 we do want. So same thing. We want our next pointer of this to be this. So we're going to take our node 3 and put it here. And so we can get rid of this. So this 4 still points like this. Right, we haven't gotten rid of that. But notice that it doesn't matter because nothing points to the 4, so 4 will basically get garbage collected now. And now our head is over here. And then same thing, we move up our head. This is technically still pointing. This is pointing here. We're going to get rid of that. Okay. And we don't want the 1, so we keep going. And then we do want the 2, so same thing. So our next pointer of our current node is going to point to this 2, which will be over here. So this will point like this. And there's one here as well. Yeah. Okay, and then we move up our current node, and then we say our current next is null. This already has a null node. So this is basically going to be the result. So that the head of the list will now be null. Our current node will be over here. These two nodes do still exist, but nothing points to them, so they basically just get garbage collected. And now this is our new list. So the current node is going to be the end of our list, and now we just want to return the next node of the dummy. That's why the dummy is really useful. So essentially, just to recap, we build a dummy and a cur equal to it. And if we want to add nodes, we can just say cur next is a node we want to add. And then we move the current up, and then we make the next of our current null. And we just keep doing that until we get this whole thing. And that's basically it. And then we turn this into a set in the beginning. Okay, so let's do that. So first we'll make a set, so we'll call like bad numbers or something. Equals for every number, we will put it into the set. Okay. Now we're going to make the dummy node. And it doesn't need to have a next node or a value. We're not going to use it. We just need it to know where the head of our list is. So actually, it needs to be like this. We don't need to give it anything. We'll use this constructor. And then we'll say the current node will equal the dummy. Now we'll say while head does not equal null. Let's just keep doing this. So if the head value is not in bad values. So if it's not in here, then we want it in our list. So we'll say cur next equals this head node, cur next, or cur equals cur next. Then regardless of what we're doing, we can say head equals head next, and we can say cur next equals null, and if it was null already, it'll be null. So basically, if we didn't use a node, this will do nothing. If we did use a node, that will clear up the old connection. Yeah. And I think that should be it. And now the cur is going to be the end of the new list we made, and dummy will be pointing to the head of the new list we made. So now we just return dummy next. And so this is very useful. So I'd recommend for almost all problems where you have to move nodes around, just make a dummy node, and then you know exactly where's the head of your list. Same thing for like if you have a, instead of a one-sided linked list, I forgot the name, like one-sided, two-sided linked list, you can make dummy nodes on both sides. So that also works. Yeah, so I think that's going to be it. Let's see if this works. Okay, yeah, it does. And this is also useful if you're going to build like a linked list constructor. You can make a dummy node point to something. Instead of checking like, is the head null, is the tail null, is all these things, you can make a dummy node on one side, and if it's I forget why, I keep drawing a blank on the type of list, but if it's a list that goes in both directions with an X and a previous, you make a dummy on both sides. And then you just put nodes in between. So this case, and the main thing you want to remember for these problems is almost never, so for I'd say 95% of the time, you never have to make new nodes other than this like dummy node. You never have to like copy the nodes. So if you're looking to copy the nodes, that's probably bad almost always. And yeah, so almost all these solutions are going to be O of 1 space for linked list problems, like 90+%, and O of n time. So that's another thing you want to look for, is you almost always have a linear solution for all these linked list problems. Okay, so this will be linear because we're basically just going from the head to the end, and like I said, O of 1 because we just have these two nodes. And this is a really common pattern you can use to reverse a part of a list, or move nodes around, or combine two lists, or whatever kind of thing. You would basically just keep adding to the end of this current node. Yeah, so pretty easy one. Hopefully this pattern is useful for you. If it is, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.